Patrick, so you were watching and listening to the notes on interval notation. This is something that is in addition to our Algebra 1 curriculum, so it's a little bit of an extra, but I really think it'll be beneficial for you as you move through your math classes. So it's called interval notation, and interval notation is another way for us to write inequalities. So if we look right here at this inequality, -3 is less than or equal to x, which is less than or equal to 5. There's another way that we can write that called interval notation. Before we do that, we're just going to go ahead and graph it on a number line like we normally would. And we're going to have a closed circle at -3, as well as a closed circle at 5. Both of those have an equal to on their symbols, so they will both be closed circle. Then we know that because x is between both numbers, okay, that we shade between both of the numbers on the number line. Okay, and if you think about it, okay, if we just look at this section, x is greater than or equal to -3. So we shade it over here to the right. Okay, and then if we look just at this section, x is less than or equal to 5, we shade this direction. Okay, and then what happens is that overlapping region between them, that is the solution set. That's where all of the numbers satisfy this set. Now, when we write interval notation will use parentheses and it will use brackets. So one thing I want to show you, okay, is if we are using a bracket, that means that we have a closed circle or we have an equal to on our inequality symbols. If we're using a parenthesis, that means we have an open dot with less than or greater than. So those things go together. So a bracket represents a closed circle or an equal to symbol with the inequality, parenthesis, open circle. Okay, so if we were to write -3 to 5 in interval notation, we would do a bracket on -3 and a bracket on 5. So we do -3, 5. That shows, first, that we're going from -3 to 5, but second, that the brackets are there to show that those values are included and we have closed circles. Okay, let's do another one, and it will start to come together for you. We're going to do an open circle at -6, an open circle at 4. Okay, and again, we're shading between the two. Because if you think about it, if we just do this section, x is greater than -6, we shade it to the right. If we do the other section, x is less than 4, we shade it to the left from the 4. All right, so if we put this in interval notation, you'll notice that we don't have equal to symbols. That means we're going to be using parentheses. So we would write this as -6 to 4, just like that. It kind of does look like a coordinate point, but it's not. It's just another way to write that set. Okay, letter C. Let's do another one. We're just going to keep practicing these until it starts to click for you. We're going to have an open circle at -4 and a closed circle at 8. So open at -4, closed at 8. Okay, now this is where the shading of the same and the center is the same, but this is where when we write the interval notation, one of them is going to have a parenthesis and one of them is going to have a bracket. So take 2 seconds on your own notes. Okay, see if you can pick out which one is going to have a parenthesis and which one's going to have a bracket. Your parentheses should be on the -4 because there's no equal sign on that one, and the bracket should be on 8. Okay, now we're going to introduce something new. We're going to introduce this idea of infinity. Okay, in part D, Part D is saying that x is greater than or equal to 4. So if we graph that on our number line, it will be a closed circle at 4. And then you want to look at where are the numbers greater than 4. Well, over here to the right is where our numbers are greater. Now, this does not end over here, so we're going to say that that line or that arrow is going to go to infinity. Infinity will always get a parenthesis. Okay, for infinity will always get parentheses. But in this case, the 4 will get a bracket because of this guy right here. So the 4 gets a bracket, but the parenthesis goes with that infinity. Now we're going to take a look at E. Okay, E, we're going to have an open circle at 5. Okay, and its x is less than, so we're shading to the left. Now, on this one, it's different than part D. On part E, we don't have equal to, so there's going to be all parentheses here. But the one thing that is different here as well is that we're going to negative infinity. Negative infinity is lesser. So when we write this, we always go from left to right. So we write least to greatest. So for our interval notation, we'll have negative infinity to 5. Okay, the infinity always gets a parenthesis. The 5 gets a parenthesis because it was just less than in part B. Okay, part F. This looks different, right? We're used to having x on the other side, so we're going to rewrite this. Okay, and its x is greater than negative 4. So I just flipped them around. I made it easier. That's what we're used to seeing, so we're going to write it just like that. We're going to put an open circle at negative 4, and x is greater with shade to the right. Okay, so you always go least to greatest. So on the very left is negative 4. Okay, and on the right, over here, is infinity. Infinity always gets a parenthesis. Negative 4, in this case, gets a parenthesis because of just a less than symbol. No equal to on that one, so it has a parenthesis. Okay, one of the greatest advantages of interval notation is that we essentially just need to know that the starting and ending value, what the starting and end values are, and whether or not they're included. That's all we have to know. So if you look at example 2, it says which of the following represents the equivalent interval. So if we look at negative 12 is going to have a bracket because of that equal to. If we look at 4 is going to have a parenthesis because it's just a less than. So if we look down here, ours will match up to letter B. Negative 12 to 4, but that negative 12 is included because it has a bracket that has that equal to symbol. Okay, so now we're going to look at example 3 here. Okay, and we've talked about solving inequalities before. And before we even graph this, we have to know what x is. We have to have x on one side. So our first step is going to be to subtract 12. Then we'll divide by negative 4. Keep in mind, when we divide by a negative number, we have to flip that inequality sign. So now it's going to be x is less than, and then 3 on that side. So if we graph it, we'll have an open circle at 3, and if x is less than. And I want you to write the interval notation. This is just what we got finished doing. So see if you can write the interval notation that matches up with x is less than 3. So you're going to write that interval notation. I'll give you just a second here. Okay. Hopefully you see that we're headed towards negative infinity over there. And negative infinity should come first. Okay? Infinity, again, always gets a parenthesis. The 3 will get a parenthesis because it was just a less than symbol, no equal to on that one. Okay, this is a little bit different, for example, for kind of interesting, because sometimes we'll have and sometimes we'll have the word or, and I'm going to talk about the difference between the two. So it says two inequalities have solution sets written in interval notation. So we have inequality 1, we have inequality 2. In part A, it says write an interval that represents all values that are solutions to both inequalities. So we want an overlapping region here. Okay? So what we're going to do first is I'm going to color code this. Our inequality number 1 is going to be red. And our inequality number 2 is going to be green. Okay, so I'm going to draw my red one first. And I'm going to use a number line because I think that number lines will make our life a lot easier. We're going to put 0 right there in the middle. Okay, here's negative 3. And here's 2. So if we look at just our inequality, number 1, I'm going to go ahead and graph that one. There will be a closed circle at negative 3, and there will be an open circle at 2, and we draw between. Okay, now our inequality number 2. We will have an open circle at 0, and we will have an open circle at 4, and we draw in between. So our goal in graphing both of those is to find the solutions for both inequalities. So we want an overlapping region, and our overlapping region happens to be right here, from 0 to 2. But what I want you to notice is that 0 and 2 are not included for both the red and the green. So when we write this answer, we have to use parentheses because those are open circles. Okay, now I'm going to copy and paste my number line to this other section here. So bear with me while I copy and paste. Okay, so we needed the same number line. So the number line is not going to change because we're still dealing with the same inequalities. But what's different is that it says write the interval that represents values that are solutions to either of the inequalities. So it really includes everything that's on our number line. So we start here at negative 3 and we end at 4. But what you have to be careful about is the endpoints. Here at negative 3, we're going to use a bracket because it's a closed circle. But over here at 4, it's an open circle, so we're going to use a parenthesis. So the difference between and or is and is an overlapping region, or includes everything that you drew on that number line. All right, example 5. A hydroelectric plant has pump number 1, and it's on from interval 0 to 8. Pump number 2 is on for all times from 4 to 18. Which of the following represents all times when both pumps are on? I really think that visually it will benefit us to look at this, so we're going to draw a number line. Okay, we draw a number line, put 0 in the middle. Actually, you know what? Hope you used your pencil. We're going to erase that. We're going to put 0 over here, because if we look at what we're dealing with, we're dealing from 0 to 8 and from 4 to 18. All right, pump number 1 is going to be in red. So, pump number 1 goes from 0 to 8. Okay, now if you look at 0, it's included, so that's going to be a closed circle. 8 is going to be a open circle. Then we'll shade between. Okay, I want you to see if you can draw the interval for pump number 2. Okay, you should have a closed circle at 4 because of the bracket up here. And then over here on 18 is a parenthesis, so that should be an open circle. Okay, now if we want to know when both pumps are on, right here, in this overlapping region is when both pumps are on. So from 4 to 8. Okay, they're from 4 to 8, but you have to decide which one is on at that time and which one's not equal to that time. So here at 4, we have a closed circle, meaning we're going to have a bracket. But over here at 8, we have a open circle, so we're going to have a parenthesis on that one. So from times 4 to 8, only including the 4 is when both pumps are on. All right, go ahead and work on the practice problems. Okay, the practice key is in the extension module. Okay, so you can check your answers for the practice.